picking up on number 3. And remember, we're talking about our position, velocity, acceleration. So as we pick up at number 3, a comment up above, before we get into it, some motion problems will require you to find the actual position of an object or particle at a given point in time. Remember that you will need to use initial conditions in order to find an actual position, since the definite integral only provides the change in position of an object. Okay, so we will be working on finding that actual position at times. And again, use the information provided. Now, as we look at 3, an object moves in a straight line with a given velocity of square root of 3t minus 2 meters per second, where time t is in seconds. Always pay attention to your labels there. At t equals 5, the object's distance from the starting point was 12 meters in the positive direction. So our first job here is to write an integral expression. Not solve it, not doing anything fancy. Write an integral expression that will compute the object's position at t equals 10. Okay. So how are we going to find the object's position at t equals 10?
Well, you gotta integrate the square root of 3t minus 2.
Okay.
To get your position.
Okay, so since this is velocity, in order to get our position, we're going to integrate the velocity. So we're going to integrate the square root of 3t minus 2. I could have just written that as the integral of v of t also, but that's right. Oh, and what should I have on here at the end? dt.
Change it to the integral of 3t minus 2.
We don't actually have to integrate.
Oh.
So I'm just going to leave it as a square root, but I need some more information.
0 to 10.
Not exactly.
Oh, integral expression.
Okay. So we're going to use 5 to 10 because what do we already know?
At 5, it's 12.
At 5, it's 12. So we're starting at 12 at 5. That's kind of our starting point now. And then we are going from 5 to 10. Okay? If you look back from what we did yesterday, right here is where we're at. Actual position. Your initial condition plus whatever is going on over the interval. So our interval is not 0 to 10 because we have an initial condition at 5. And yeah, so I have it kind of commented in my notes that it's the initial plus the displacement. So the change from 5 to 10. That's what we just did there. But all we needed was the integral expression. B says to use a graphing utility to find the actual position of the object at 10 seconds. So what does that mean we're doing? You're taking your graphing utility, aka your graphing calculator, and plugging it in. I'm not graphing anything. Graphing utility just means use your graphing calculator. At least that's the way I take that.
So if it's yellow, does that mean it's graphing?
Where's that pause? Hit enter and see if it keeps going. Because enter will pause or unpause. Because I don't remember off the top of my head. Does that answer your question?
Yeah.
Now, I'm not graphing anything though.
What? I'm so confused.
All you have to do is type in what's on the screen there. The
Oh,
12 plus
not
the
Into a
integral.
graph?
There's no graphing. We're just finding the integral.
I got 34.
That was
34.508.
Okay, so you're just typing the 12 plus the integral into the calculator, getting an answer, because, no, we have a lovely little calculator sign over here, right?
That's meters.
34 point, what'd you say? 50 what?
9.
509 would be the rounded version. And that is, what label did you give me?
Meters.
Meters. Okay,
Some people do
so AP Calculus, what'd you say?
the before you said we could do like we could just cut it off after the third.
You can, I didn't think you said 8.
Yes.
I don't know what I thought I heard you say at the time, but maybe you did. Yeah, 34.509 is the rounded to 3 decimal places. You can also truncate to 3 places, and so you'd be okay to say 34.508. Okay. Okay, questions there? Okay. Let's go to example 4 then. The particle is moving along the x-axis with given velocity, negative t squared plus 7t minus 10, measured in meters per second after t seconds, with an initial position, s of 0 equals negative 3. Okay, so note initial position. That's going to be key. Determine the displacement of the particle on the time interval 1 to 7. So the displacement of the particle on the time interval from 1 to 7. So what are we going to do here?
Negative 3 plus 1 to 7. B of t.
Actually, not exactly. We want the displacement between from 1 to 7. Does that have anything to do with time 0?
Nope.
No. So are we actually going to use that 3 on, or that negative 3 on this piece? No. Okay. So displacement, now what the other piece you said, we're trying to do the displacement. And again, that's something that was on that first page yesterday, right? Yeah, displacement. We're looking here at the integral from 1 to 7 of negative t squared plus 7t minus 10 dt. So again, to find that change in placement, we are looking at this. Now, let's do this one by hand. We don't have a calculator symbol. And we're going to have to talk about part of it by hand here in a little bit. So let's do this by hand. Let's integrate. What do we know?
Negative 1/3 t cubed
Negative 1/3 t cubed
plus 7/2 t squared
plus 7/2 t squared
plus 10t. Minus 10t.
minus 10t. Sorry, that was me checking to see if I copied the sign wrong or if you said the sign wrong. Evaluated from 1 to 7. Okay, let's do some math. We're going to start by putting in the what? The 7. So negative 1/3 times 7 cubed plus 7/2 times 7 squared minus 10 times 7. And I'm just writing it out. I will do the cleanup here in a moment. And then what's the other piece of this? That's putting in the 7, and then we are going to plug in 1, and it's going to be subtraction, right? So I'm going to say minus the quantity, negative 1/3 times 1 cubed plus 7 halves times 1 squared minus 10 times 1.
7 cubed.
7 cubed. Well, 7 times 7 is 49.
343.
Okay. Times a negative third is going to make this negative 343 over 3, if you will. Plus 7 squared is 49. Times 7 is going to be 343. This time it's over 2. Minus 10 times 7 is 70. Okay. And second piece, remember it's minus everything over here. So negative 1/3 times 1 cubed is going to be,
Plus a third.
yeah, it's negative 1/3, but minus a negative, so plus a third. 7 halves times 1 squared,
Minus 7.
7 halves, but we are subtracting everything. Minus 10 times 1, minus negative 10, so it's going to become plus 10. Okay.
I lost room. I'm putting more room.
Go off to the side. I don't know. Okay. With this in mind,
Can I add the thirds and the halves together?
well,
Right.
and that's, yeah, I was just glancing at mine to see what I did. I added the thirds, the halves, and the whole number. So now I'm down to 3 pieces, and then I get my common denominator. Because you're going to have to go for common denominator if you're not using a calculator. So if we add our thirds, negative 343 thirds plus a third is going to be
342.
negative 342 thirds. 343 halves minus 7 halves is going to be,
336.
that's what my brain says, is that right? 336 halves?
Put it on the calculator, but sure.
And then minus 70 plus 10 is minus 60. And then if we're not putting it on a calculator, we've got to go somewhere. I think, actually, do I need a common denominator, or do those all divide nicely?
They divide.
They all divide to be whole numbers now that I look at them. I didn't catch that in my work, though, because I went on to get a common denominator of 6 in my book. Well, here's what I'm looking at. 336 divided by 2. I know that can divide nicely. 342 divided by 3. Well, I know 3 divides by 3, and I know 42 divides by 3. So, these can become whole numbers. 342 divided by 3. If you're not sure,
I am doing long division right now, and I'm so proud of myself. This is crazy. Negative 114.
yep, see? It's doable. So, negative 114 plus 336 halves, so half of 336.
Shoot, I keep
I think.
168.
That's what my brain said. Is that right?
That's what I got doing division. I don't care.
I don't either, but I normally just can do it in my head, but I'm double checking myself. Okay. Well,
Negative 6. Because you subtracted the 60 from 168.
150.
okay. So you're looking at, then that makes it negative 114
Plus 108.
plus 108. I can see that. And it's all, my brain was going to put my two negatives together and then just do one subtraction. But I like what you did. And it's all, here's the deal, it's all what your brain sees, right? So, we are at negative 6.
6.
And guess what? Even though I didn't do it the same way, it matches my answer key.
Perfect.
Negative 6, what?
Oh. That's funny.
Okay, I'm going to go with your meters. My answer key says feet. But I see nothing about feet in the problem. Do you? What was I thinking at the time?
Thinking like an American.
Maybe that's the key. Unfortunately, so many of our math problems are not American, are they? Now, what does that mean in terms of displacement? -6 meters. Displacement is where you are in relation to where you began, so that is,
Left back 6 meters.
yeah, or 6 feet to the left is what I have it written as.
Like, sorry. Go back 6 meters.
Oh, I just wrote feet because that's what I just, 6 meters left is what I was trying to say. Goodness.
No, sorry, doesn't have any this chart.
Okay, now, next one. What is the total distance? So again, if you go back to page 1 yesterday, we talked about how to deal with total distance. Total distance traveled by the particle on the time interval 1 to 7. Okay, so officially, we have to think about the absolute value. So it's still on the interval from 1 to 7, but we're doing the absolute value of v of t dt.
Wouldn't it just be 114 but positive?
No. Here's the deal. When we talk about, because if you go back, so let me backtrack to yesterday. Maybe, I'll get there. Okay, when we talked about total distance, okay, so like here, with displacements, A1 ends up being minus A2 plus A3. With total distance, it ends up being A1 plus A2 plus A3. So when we talk about absolute value in terms of this integral, we have to figure out, okay, which sections go negative. So what we're going to have to do is we're going to have to consider the graph. So let's see. I'm going to get rid of my division. It's in my way right now. But I want us to consider negative t squared plus 7t minus 10. Think graph with me. Can we agree with Mario? Upside down parabola. Negative t squared upside down parabola. Now, where's that parabola going to cross the x-axis?
At whatever
5 and
the
10.
zeros are.
Okay, whatever the zeros are. So let's find the zeros. Okay. Now, for me personally, before I factor this, I'm going to factor that negative out. So if I factor that negative out, I'm now working with t squared minus 7t plus 10. Are you with me on that? And then if I factor that, which is what you guys were trying to already do, which was good, t squared is t and t, multiplying to be 10, adding to be negative 7, minus 5 minus 2. So that means I'm going to have zeros at 2 and 5. So if we're thinking about this parabola, we're going to cross at 2 and 5, and we know it's an upside down parabola, yes? So what does that mean?
The distance traveled is just positive.
But it's total distance traveled. So even when you're going backwards or left, that's still part of your distance. Okay, so like total distance, if I go forward 5 steps, and then backward 2 steps, and then forward another 3 steps, I'm adding all of those distances for total distance. Okay, when we're looking at this, we're basically looking at the fact that, what are we going from 1 to 7? We're going to have some underneath piece here. We're going to have some above piece here, and some underneath piece there.
Oh.
So what we need to do to consider this is when you're doing this by hand, you're breaking it up into multiple integrals. Okay? So I'm trying to get you to realize that since it's the absolute value, breaking it into looking at those pieces. So like the first piece is going to go from one to two because it's the piece that's below. So it's the absolute value of the integral of v of t from 1 to 2. What's the next piece? 2 to 5. And that's the piece that's already up above. I'm still going to write absolute value. But that's the piece that's already up above, yes. And then the third piece is the piece from 5 to 7. And that's the other piece that is down below.
Oh, shoot.
Now, I have values in my notes. Did I get these values? I don't have the work here. So, did I get the values from my calculator? I don't have work here, so I must have just used the calculator, which strikes me as odd here, but probably trying to save work so we're not having to do this same problem 3 times. So if you put in the calculator, the integral from 1 to 2, so we're going to have to do this piece by piece, and what is it we're doing? It's negative x squared plus 7x minus 10. Okay, so there's the integral from 1 to 2. And I have them in fractions in my notes. So the integral from 1 to 2, negative 1.8 and then 3 repeating, as a fraction is negative 11/6. Does it make sense that it's negative?
Yeah.
It should make sense. Whoops. I erased too much there because I was putting that in the wrong spot. It should make sense that it's negative because from 1 to 2 was below the x-axis. So that's going to be the absolute value of negative 11/6, which is going to become 11/6, but we'll talk common denominator 2 here in a moment. Plus, what about from 2 to 5? Now I'm going to go up and copy and paste and just change my boundaries. .5, which is what is a fraction? Nine halves. Okay. Which, does it make sense that that one came up positive? It's that middle section, yes? And then we've got one more piece. Five to 7. Negative 8.6 repeating. Which is, what is a fraction? Negative 26/3. Okay. Absolute value means these each are going to become positive. Denominators of 6, 2, and 3 should become denominators of 6.
Should be 6. Did you go to 12?
Yes. Why? Okay, 9 halves multiplied by 3, 27/6. 26/3 multiplied by 2, 52/6. Makes me wonder if I did 12ths or if she did 12ths. And I just went with what she did. I don't know. I normally try and work the math on my own though, so. Okay, if I did that correctly, 11/6 plus 27/6 plus 52/6
Two.
96 is what I got, right? Which, I mean, that was just me adding. And then when you divide, 6 goes into 90. I heard it out there somewhere. 15 times?
15 meters.
15 meters.
Gosh, I just love calculus.
I really want to know what I
I
was
was doing
doing.
myself.
You were.
I was.
Why'd you say maybe?
Okay. Difference between displacement. We're adding all the, it was just difference between beginning and end. Take into consideration, all the changes. Total distance, that is the total that you've walked, traveled, moved, whatever. So you have to include those negatives that took us left or backwards.
So what was the point of having S's?
Nothing. Now, okay, would it have made a difference though if our interval was 0 to 7?
Yes, because then we could have just added the -3 in there.
Because then it would have been -3 plus whatever we got. But since it didn't talk about, we didn't go down to 0, it didn't matter. Now, was that maybe a typo on her behalf and not what she meant to happen? I don't know, but it's what's here, so. Okay, 5? Ooh, we got 5, 6, and 7 to try and get through.
1, 6, 6.
Okay, suppose you are driving in traffic behind a large bus at 66 feet per second. This is 45 miles per hour. When you finally get a chance to pass, you step on the accelerator, give the car an acceleration of a of t equals 4 over the square root of t, where a is measured in feet per second and t is measured in seconds. A, how fast are you going 16 seconds later when you have passed the bus?
We're not supposed to pass buses.
That's good.
Never mind.
Okay, work with me here. What are we being asked? How fast are you going? So what is that being asked?
Velocity.
We're trying to find velocity. What do we know?
A of 2.
We know acceleration. What is the relationship between velocity and acceleration? Depending on which way we're going,
Velocity is the derivative of acceleration.
okay,
Acceleration.
acceleration is the derivative of velocity.
Velocity is the
Velocity is the integral of acceleration. I know.
Jeez, get it right.
We've got to get all.
Yeah, I know. I have 2 ways to say it. I have 2 ways to say it.
So it all depends. It does all depend on how you say it. But since we're trying to find velocity and we know acceleration, I'm going to talk about the fact that velocity is the integral of acceleration, and we're trying to find velocity. So that means that we are going to find v of t by integrating 4 over the square root of t dt.
Yeah, have a calculator.
Oh, it does, doesn't it?
Yeah.
I was integrating by hand. What would you have to do to integrate this by hand?
Make it a negative 2.
Can you integrate that
Yes.
on the calculator?
We don't have bounds, so you can't integrate on the
That's what I
calculator
thought.
technically. Yeah, I didn't think about that.
Yeah.
So we have the calculator, but we'll use it for other pieces. Okay, so this is t to the 1/2 in the denominator, which is t to the negative 1/2. So we're integrating 4t to the negative 1/2, which, I don't know how you want to think about this. I'm going to say the 4 is already there. Ignore the 4 for a moment, just copy it down. T to the negative 1/2. If you add 1 to the power, it's going to become Positive 1/2. If you divide by that power, dividing by 1/2 is multiplying by 2. So 2t to the 1/2.
Yeah.
And then officially we should say plus c, because we don't have bounds, do we? So I'm going to clean this up a little bit. V of t is 8 square root of t plus c. Well,
That's C45.
no.
66.
Yes.
Because that's the initial.
Staying a second.
That's your initial.
45 is 2. That's not.
Okay, so yeah, right here, 66 feet per second is your initial. And I was being nitpicky. Doug said 45 at first. Why did I pick 66 instead of 45? Because A is measured in feet per second per second. So we need the feet one. Okay, it's all about what we're labeling in. So right there, our initial is 66. So we know V of t is 8 square root of t plus 66. What are we supposed to be doing? How fast are you going? 16 seconds later, so V of 16.
That is the number 2. That is 32.
That's at least.
Square root of 16 is 4 times 8 is 32. 32 plus 66, well, my scratch work off the side says 98. I don't know why I'm in such a scratch work mood today, but
Meters per second. Or
Actually, feet per second.
feet per second.
Or 66.8.
Yeah, we're in America.
repeating miles per hour.
I'm sorry. I'm
As a
sorry.
Only Americans have this.
Does that work? Does that, I did the math right for that, or do you not have miles per hour?
I didn't hear what you said, honestly.
66.81 repeating miles per hour.
Not a clue.
Okay, because I did 1 mile over 5,280 feet, 60 minutes over hours, 60 seconds over minutes,
That's good.
and multiplied to 98.
Something like that.
Okay.
I'd have to look at it to double check it. Okay. How far did you travel during this time? During that time? What are they asking me?
Distance.
Distance.
What type of distance? Total distance. Okay. They didn't come out and say, what was your total distance during this time? But how far did you travel is total distance. So how am I going to do total distance?
Integral.
That's more along your lines of your position.
We do integral of 0 to 16.
Okay.
Okay.
Of V of t.
Okay.
If we're trying to find total distance,
Oh, yeah.
it's the integral of velocity. And it's going to be from 0 to 16. But we have to do what with the velocity? Since it's total distance, we want to include positives and negatives. So we want to think absolute value again.
V of t.
So as I write this, the integral from 0 to 16, the absolute value of V of t dt. Okay, there's your general starting point. Now, we know v of t, yes?
Yes.
So it's going to be the integral from 0 to 16 of the absolute value of, I have to find it,
8 square root of t plus 66.
8 square root of t plus 66 dt. Actually, I wrote square root of t. What should I really have written to get ready for something? I'm going to change my square root of t to t to the 1/2. Yes. Now, okay, we're saying absolute value. Think about this graph. What's a square root graph look like?
I don't know, but I know that absolute value graph
It's a
looks
little
like.
Well, don't worry about absolute value.
It's rainbow. Thing.
Half of a sideways parabola?
Oh.
That's your square root. Okay, like if this is, that would right there would be y equals square root of x. What's the 8 doing to it?
stretching.
Stretching it. So now it does something like that. What's the plus 66 do to it?
Translates it up.
Now it's up 66 units and goes something like that. All of this to say, are we going to have a negative portion?
No.
No, this graph's never going to have any zeros between 0 and 16. And so, do we really have to do anything different here?
No.
No. You can do this fully by hand. Okay. Do you see my idea? This is why we know our graphs, right? So we can kind of visualize these things and, rationalize, okay, yeah, it's always going to be positive. So, 8t to the 1/2. I'm going to add 1 to the power. So that's going to be t to the 3/2. We are on a calculator problem.
Yeah.
Well, okay.
No, not trace. Not zero.
Okay, well, meet me in the end with the answer, I guess. I don't know. Add 1 to the power, 3/2. Dividing by 3/2 is multiplying by 2/3, so 16/3 t to the 3/2 plus 66 66 t evaluated from 0 to 16. Okay, I do agree. We have the calculator. I don't know. 16/3 times 16 to the 3/2. That's the square root of 16 cubed.
Kidding.
Plus 66 times 16. What's going to happen if you plug in 0?
It's gonna be 0.
Both pieces are going to be 0, aren't they?
Yep.
Okay, always check that. Don't ever assume that. So, okay, and then I have a decimal. I have all that work, and then I have a decimal. Don't ask what I was thinking. I wasn't.
You realize.
Did you guys already do it on your calculators?
1397.33.
Calculator says
Over
1,397.333.
Feet.
You basically
That's
drag
a
race.
long
Feet.
bus.
You basically drag race this bus because the drag race is a quarter mile and that's 70.
Now, here's the thing. It says 16 seconds. It's 16 seconds later when you have passed the bus. Was it
It
really
doesn't
saying
mean
you took
passing
the
the bus.
whole 16 seconds to pass the bus? That's not how I interpret it. I said,
Not what
to
I
me,
thought.
it's you started passing the bus. I don't know how long it took you, but then total of 16 seconds later. So maybe the first 5 seconds you were passing the bus, and the other 11 seconds is just travel time.
Yeah, you just.
I passed a car this morning. It was so stupid because then I just got behind another slow car, and then the car
There is no point of passing vehicles on the way to or from school because you just get caught. Okay, moving along. We've got to do 5, 6, and 7. We're not going to make it.
Oh.
Okay, average velocity for the 16-second interval.
1/16 times the interval.
Okay,
Oh.
okay. So when we talk about average velocity, we can talk about this,
So is this a rock then?
or just average value. Remember we learned that average value function where you do 1 over b minus a out front? I have it written down in two different ways, okay? So when we talk about average velocity, one option is you can think about displacement divided by time. Okay, that's one way to talk about average velocity. In this case, our total distance, that bus is always moving forward, or we're not the bus, are we? We're always moving forward in this problem, right? So our total distance is the same as displacement in this case. So you can think displacement divided by time. You can also think of it as what we are learning in this lesson, where to do the average value of the function, 1 over b minus a, so 1 over 16 minus 0, times the interval of 1 to 16 of v of t dt, yes? Either way, whichever one you think here, you're doing 1,397.3 repeating divided by 16. In other words, we've already done this, yes?
Yeah. That's total distance though, not displacement.
But that's what I was just saying, that in this problem, if I'm always going forward,
Oh wait, yeah, never mind.
right?
Yeah, I did this.
In this problem, now, am I saying displacement and total distance are always the same? In this particular problem, because there's no left to right, forwards, backwards, they are the same. Is my argument sound here?
Yes.
Okay. So either way, it's 1/16 times 1,397.333. What's the calculator tell us? 87.333 per second. Okay. It's wrapping our head around all the physics stuff. Let's see if we can at least talk about dropping our calculus book. Obviously, 7's probably not going to happen, which is a bad thing, but
Destroying calculus.
not destroying calculus book.
Yeah.
Dropping it. Well, okay, these it would destroy. This is not a typical calculus book, but you drop your calculus book from a window 48 feet above the ground. How long will it take your book to reach the ground? And then what is the velocity of the book at the instant it reaches the ground?
What's the terminal velocity?
What?
Does that mean, like, would it have enough time to reach its terminal velocity? That's the question. Why we didn't.
That is not a question I'm answering.
Okay.
Maybe I just don't know enough about my vocabulary there, but okay. How long will it take your book to reach the ground?
So when t equals. Never mind.
We're trying to find t, right? How long?
Yes, and when velocity equals 0, or
I feel like we're not given.
Oh, you know we're given enough.
you're given.
Okay.
That's enough.
That's enough.
That's enough. So,
So that's what it is.
okay, what do we know? You drop being a key word,
Negative.
okay? You drop your calculus book. What is your initial velocity?
0.
0, because you didn't put any force behind it, right?
Yeah.
So we're going to start off with, at time 0, our velocity is 0. I'm just trying to gather some information here. I need to get my head straight. And that's because we drop. Now, we talked earlier this year, what's the acceleration?
Also 0 because you're not doing anything to it. It's just there.
You're not doing anything to this book, but what is
Oh.
doing something to this book?
Negative 8.1.
Gravity. But we are talking about
Oh.
feet. So you don't get to
So-
use the
16.
So we talked about this earlier in calculus, but you're not going to remember as well as you know. It's 9.8 meters per second when we talk about it in non-America. So we need to talk about it being 32. And because it's the gravity due to the Earth,
Then what's the 16 one?
Your velocity.
No.
that's, yeah, velocity.
Yeah.
Mhm.
Because it's negative 16.
Okay. Oh, I didn't fill this in. This should be A of t. What about position?
48.
My initial position is 48 because we are 48 feet in the air. Must be your dorm window or something. I don't know. Okay. So that is our initial information. In terms of formulas, we have an acceleration formula, yes? Acceleration is negative 32 feet per second squared. What can we find since we know acceleration?
Velocity.
We can find velocity because velocity is the integral of acceleration. So I just wrote it in general. V of t is the integral of A of t, but A of t, so we're going to be doing the integral of negative 32 dt. If we integrate,
32t plus c.
okay, negative 32t plus c.
C plus 40.
Well, how do we figure it out?
C. Do your initial.
Officially, we would want to go based on the fact that, oh, wait a minute. We're not to a position function yet. Okay, so right here, if you just go with what we know that v of 0 is 0, so v of 0, when you plug 0 in, negative 32 times 0 plus c, v of 0 equals 0. Are you with me here? What about the rest of you?
Sure.
Yeah.
V of 0 equals 0. So I'm using that initial information. V of 0 equals 0, so you plug 0 in. Negative 32 times 0 plus c equals 0 tells me that c is 0. So what does that make my velocity equation?
Negative 32t.
Negative 32t. Okay. Now, next place we need to go with this is position. Okay. How do you find position?
The integral of
It is the integral of velocity. So I'm going to use S. S of t is the integral of velocity.
Oh, okay. Now I get where you get 16.
Okay, so then S of t is the integral of negative 32t dt. We're going to integrate, add 1 to the power, divide by 2, the new power, so negative 16t squared plus c.
And C is 48 or is not 48?
Well, prove it. What do we know?
Oh, yeah.
S of 0 is 48. So if I look at S of 0, so taking in and plugging in 0, and then it's going to equal 48. Did we follow that better this time? S of 0 equals 48. You do the magic and C is 48, isn't it?
Yeah.
So now we can write our position function. S of t is Negative 16t squared plus c, which is plus 48. What were we being asked?
How long?
T. How long will it take for your book to reach the ground? What do we know about the ground?
That's 0.
It is a position of 0. So we're going to say negative 16t squared plus 48 equals 0. Good. Okay. So, I don't really have time to finish this, do I?
Negative.
T equals square root of 3.
Yes. That's not negative square root of 3, that's again negative 10.
I say technically plus or minus the square root of 3. You want to be careful with that in a physics setting, though, because you can sometimes get negative times, but you would not in this scenario. So it is square root of 3 seconds. Okay.
Oh, I'm dividing it. Okay.
Sorry, that was me quickly solving.
It's okay.
B would be easy. What's the velocity at the instant it reaches the ground? That's plugging our square root of 3 into velocity equation. So that one would be easy. Okay. I lost my velocity equation though. Negative 32 times square root of 3, whatever that is. We did not get to 7 at all.
And
I don't remember how important it is to homework. Do keep in mind, you have access to number 7 in the notes. So you can have an idea of what, we're doing there. Go through the homework, do the homework. Let me know where the issues are tomorrow, right? I think it is like 4 full pages of homework, so. Okay.